Hello everybody. I hope everybody's doing well. By now you should have watched the two videos that went along with lesson 13 that we had begun on March 12th on Thursday, and you had 1 to 5 from this packet. And the two prior videos I went through all the problems on this packet as well as gave the homework answers. And if you had any questions, hopefully you emailed them to me, because now I'm going to pick up on this next handout, which you should be opening up on your computer. I don't expect you to print it. You know, as long as you have this open in a window where you can read the problem, do the work in your notebook, okay? I'm going to go through the classwork, and then when I'm done, I am going to want you to do the homework. I will have all answers posted later on today. So let's begin. First, we have our 3 different types of percent problem formulas. The first one is 1 plus or minus the rate. That's for yearly. Then we have 1 plus or minus the rate divided by n, which is compounding. And then we have the continuous, which is the PERT formula using Euler's number E. So, number 1, Sienna invests an initial amount of $12,000. So, like I always like you to do, make a list. A sub 0 is 12,000. Always a good idea. In a stock, Verizon stock, in 2009. Now, guys, time 0 is 2009. We always begin our count from when the problem starts, and here it's 2009. And by 2015, so now if I think about 2015, that's 6 years. So now I'm going to time of 6 years. The stock was valued at 36,000. Now that's my amount over time. I initially put in 12,000, and then over 6 years of time, I'm now equal to 36,000. So it's important that I know what each part of the problem means before I begin. Assuming the stock compounds interest yearly. Now, because it said yearly, you have to use this first one. This is the one that's just plain old year, no compounding, no continuous. So if we take our original formula, the amount over time, and this is the initial amount, or the principal, 1 plus the rate raised up to the time, we have $36,000 is equal to the initial, the principal, the initial, the 12,000, 1 plus the rate. Now the time was 6 years because it took 6 years, 2015, to equal this amount. We're solving. We absolutely have to divide out this $12,000. And we get 3 is equal to 1 plus the rate, still in a parenthesis, raised up to the 6th power. Now, we have to get rid of the 6th power. Couple of ways we can do it. I think the easiest way to look at it, in my mind, hopefully yours as well, is the multiplicative inverse using the power rule. Take this exponent, raise it to its reciprocal, power to power, multiply, cancels out those 6's right away. Then I'm going to raise this side to the 1/6 power. Now, when I do that, 3 to the 1/6, my calculator gives me 1.2009. It's actually a little bit longer, but if you do recall in class, I said as long as you round to no less than 4 decimal places, you can write that. You should be keeping the big number on your calculator. But that, however, getting rid of the exponent, got rid of the parentheses. So now I have 1 plus the rate. So if I want to find the rate, I'm going to subtract the 1. And I have 0.2009 equals my rate. And so that means the rate that I earned, pretty good rate, move the decimal point in twice, this would be 20.1% was earned. That's a pretty good rate. That's a pretty good rate of return. So that was number one. Hopefully you followed that. Now, at any time, pause the video and get yourself caught up if you seem to be getting lost. Number two, Tyler's parents wanted to invest money for college. They invest $40,000 today. Now, whatever day today is, that's our time zero. So our time zero is the day that Tyler's parents made this investment for him. So we're just going to get rid of some of this. Let's see what I need to fill in. So Tyler's parents invested $40,000, so that's the initial amount, the principal. And the time zero is today, in a fund that compounds yearly, assuming they make no additional deposits. How long will it take to the nearest tenth of a year for a fund to reach $100,000 if they are growing at a yearly growth rate of 7.65%? So the time, I don't know. The rate is 7.65%. And we want the amount over time to be $100,000, which is roughly what it would cost 4 years at a state school if you live on campus. So this would be going to the original formula, A equals the principal, the original amount, plus the rate to the time. So when you do that, we would have, again, the original formula. And we can use principal, initial amount, I'll use the principal. 1 plus the rate to the time, because they said yearly. So now the amount is $100,000. The original principal was $40,000. 1 plus this, decimal move, remember, 2 times, 1.0765 raised up to the time. So we have to divide by the 40,000. And when we do that, we end up with 2.5. And that's 1.0765 to the time. Your exponent is an unknown. Got to use a log. So I am going to throw the natural log on both sides. So if I put a natural log here and I put a natural log here, you could use a common log. You're going to get the same answer. I just like to use a natural log. And if I leave this, I would get natural log of 2.5 is now equal to t, power rule, exponent comes down in first, the natural log of 1.0765. I want to know what the time is. I'm going to divide out the natural log of 1.0765. That's going to cancel. Natural log of 1.0765. And my time on my calculator is 12.43. So, you know, I'm rounding. 12.43. The problem said to the nearest tenth of a year, so that's actually 12.4 years. So I guess if they want to make sure they have that 100,000 by the time this guy graduates, they had to start, you know, when he was around 7 to put in $40,000, and, you know, this way they'll have enough money. So that was number 2. Number 3, when Nicole is 25 years old, she gets married and receives a wedding gift of $25,000 from her parents. Now, that's a pretty nice wedding gift. I don't think. So let's start this guy again. Let's see what we need. So she gets $25,000 as a wedding gift. And then she studied very hard and then landed an excellent job with a high salary and decides she doesn't need the money now. She decides to put the money into a mutual fund, earning 9.25% growth, compounding quarterly. So N is 4 because it's quarterly. And the rate was 9.25%. So she wants to know how long can she leave this money in her mutual fund. So the amount will be $90,000. So again, we're looking for the time. But this time we're compounding quarterly. So when we're compounding quarterly, we have to go and use the formula, the middle formula, which says the amount over time is equal to the principal, which is this guy here, 1 plus the interest rate divided by the number of times, which is now going to be the 4. And then we did it 4 times a year for every year that we have it. So now we plug in, the 90,000 goes here. The initial amount is the 25,000. And then we have 1 plus the 9.25% divided by 4, raised up to the 4 times the number of years. So one thing that you should do is you should type in the 0.0925 divided by 4 and then add 1 to it so you get a nice clean growth factor. And when I did that, I divided this, I got 0.023125. So now I add the 1 to it, my growth rate is now 1.23125. Okay? So I'm going to divide out my 25,000. And this gives me 3.6. Is now equal to 1.023125 raised up to the 4 times the time. At this point, we got to throw a log on both sides. So if I put a natural log of 3.6, and then on this side I put on a log, that's going to bring the power rule. I put the natural log on this side, and that's going to bring this guy down in front. So 4t times the natural log of 1.023125. I'm going to divide this natural log of 1.023125. And that is going to give me 56.02976,044 is equal to 4t. Now I want time, so I'm going to divide by 4. And this gives me 14.00744 years. So overall, my answer is 14 years. She puts this money in the bank. She doesn't touch it in this mutual fund. She just lets it go for 14 years, and she is going to have more than enough money, more than, the 90,000 to do whatever it is that she wanted to do with it. So again, anytime you're having trouble with the problem, you should pause the video and you should rewind and get yourself caught up.